Hello friends. So in the previous video we discussed about the mesh analysis with current sources involved at one end of the circuit network, or the simple and straightforward circuit. In this video we are going to discuss about the circuit network involving current sources in the middle, common to all meshes, which is the concept of super mesh. So we have taken a circuit network, and as you can see, this independent current source 6 ampere is located in between. Okay, so it is common to this mesh and also to this mesh. So that's why this is a super mesh analysis circuit. Okay, so first we have to assign arbitrary values to the branch currents. Okay, let us call this branch current as I subscript 1 and this branch current as I subscript 2. Okay, if we apply KCL at this point, Kirchhoff's current law, we have I1 plus 6 is equal to I2. Okay, this is the first relationship. Okay, I1 and 6, they are approaching the node, they are moving towards the node, I2 is moving away from the node. So I1 plus 6 is equal to I2. This relationship will come in handy. It is called as the auxiliary equation. Okay, it is called as the auxiliary equation. Okay, now for applying super mesh analysis, what we have to do is that we have to exclude, we have to remove this portion from the circuit. We have to exclude this independent 6 ampere current source and this 2 ampere resistor. We have to deactivate. If we deactivate the current source, it means we have to open circuit it, and once it is open circuited, it means the 2 ampere resistor also goes out of the circuit. So if we remove this 6 ampere current source and 2 ohm resistor, the circuit will look something like this. Okay, this is 20 volt, this is 6 ohm, this is 10 ohm, and this is 4 ohm. Now the important thing here is that this currents I1 and I2, they will stay the same. It means I1 will flow through 6 ohm, I2 will flow through 10 ohm and 4 ohm as usual. The only thing is that we have removed this 6 ampere and 6 ampere current source, and as we removed the 6 ampere current source, the 2 ohm resistor also went out of the circuit. Now we have to apply KVL equation in this whole circuit network excluding these two elements. So this becomes the two meshes combined together excluding the current source in between, which was common to both the mesh, as super mesh. This is called as super mesh. Okay, the meshes combined together excluding the current source common to them. Okay, the meshes combined together excluding the current source which was common to them. This is the super mesh. Now we have to apply KVL equation to this super mesh. Okay, so the KVL equation will be 20. Again I am using the second sign dominating method, KVL equation. I have already told in the previous video that you please watch the mesh analysis videos which I have posted in my channel. Around 3 to 4 videos I have posted, along with examples of solving circuits through mesh analysis. So you please go through those videos and then watch this video. You will understand it in a better way. Okay, so let us write the KVL equation. With 20 minus 6I1, okay, I1 is flowing through 6 ohm resistor, then minus 10I2, I2 is flowing through 10 ohm and 4 ohm resistors, minus 4I2 is equal to 0. Okay, the summation of voltages and voltage drop across circuit elements is 0. That's the KVL statement of Kirchhoff's voltage law. Okay, so this here it means 20 minus 6I1 minus 14I2 is equal to 0. Now we can use this auxiliary equation, this relationship in this equation. That's why it is very important to identify this relationship. So we can replace I2 with I1 plus 6 here, I2 with I1 plus 6. So 20 minus 6I1 minus 14 to I1 plus 6 is equal to 0, plus 20 minus 6I1 minus 14 I1 minus 84 is equal to 0. Okay, that implies 64 minus 64, 20 minus 84 is minus 64, and this is minus 20 I1 is equal to 0. Okay, that implies I1 is equal to minus 64 by 20 ampere, which is equal to minus 3.2 ampere. So we have found out I1. Okay, now we can use this value, put it here, and we get the value of I2. So I2 is equal to 6 plus I1, which means 6 minus 3.2, which is 6 minus 3.2 is 2.8. Yes, 2.8 ampere. Okay, so I2 is 2.8 ampere. I1 is minus 3.2 ampere. I2 is 2.8 amperes. Okay, we have calculated both the current values. So the important thing is to identify this first, the auxiliary equation, the relationship between the two branch or the two mesh currents, we can say. First, to identify this relationship. The next important thing, to get the super mesh, you have to eliminate, remove, exclude this branch involving the independent current source, which is common to both mesh. Okay, you cannot have that you still have this current source and apply super mesh. Okay, you have to exclude it. Okay, you got the auxiliary relationship, you remove the current source, then you put the super mesh equation, the super mesh KVL equation. Do not interfere, do not alter the values, the arbitrary values that you have assigned. It will remain as it is. I1 will be I1, I2 will remain as I2. Means I1 will still flow through 6 ohm, I2 will still flow through 10 ohm and 4 ohm. You get this super mesh KVL equation, you put this auxiliary equation relationship, and you determine the individual branch or mesh currents. Okay, so this is the concept of super mesh. We have understood it with the help of an example. Okay, so I hope you like this video, and please subscribe my channel Engineering Tutorial for more such videos related to electrical, electronics, instrumentation and communication engineering. Have a great day. Thank you very much.